After going through every Edexcel and AQA A-level maths past paper question, this is one of the hardest equation of circles questions that I found. So let's go through it. The question is this: we have 2 points P and Q that lie on a circle with the equation x squared plus y squared plus 8x take away 12y equals 12. So given that the origin is actually the midpoint between those 2 points P and Q, find the length of that line P to Q. Now, to be fair, this question was broken into 2 different parts. The first part was 3 marks, the second part was 5 marks. I've just combined it into a harder 8-mark question. Now, with these equation of circle questions, it's always really helpful to draw a diagram of the circles. You can actually visualize what's going on. That's what I would do if I was in the exam. Just draw the circle, try to visualize the situation here, and that's going to help you out a little bit. So we need to try and draw the equation of this circle. So to do that, we need to know what the center is, and we need to know what the radius is for this circle. So to do that, we're going to complete the square. Hopefully you can see that we need to complete the square with this equation there. So I've just grouped the x terms together and I've grouped the y terms together. So now we can complete the square. So using our kind of GCSE method, so we just half the coefficient of the x there. So x plus 4 all squared. Subtract that value squared, so subtract 16. And then do the same with the y. So half this coefficient, so we get y minus 6 all squared. And then subtract this value squared, subtract 36 is equal to 12. So then if we add the 16 and the 36 to both sides, if we do that, we should get 64, I think. 16 plus 36 is 52 plus 12. Yeah, 64. So yeah, 64 there. So we know that the radius is going to be root 64, which is 8. And the center is going to be negative 4 and positive 6. Okay, so remember the reverse of these 2 values there. So let's just try to roughly sketch this. So the center's at minus 4, 6, so like somewhere here. Let's just say that's minus 4 there. Let's say that's 6 there. Now the radius is 8, so the circle is going to go up to 6 plus 8, which is 14. So going to go up to 14 there, down to minus 2 somewhere there, over to 4 here, positive 4 there, and over to minus 12 somewhere there because of that radius of 8. So just try to roughly draw a circle for this. It doesn't have to be accurate, just something that's approximately right. So we've got the points P and Q which lie on the circle, and we know that the midpoint is the origin. So this origin is the midpoint between these 2 points P and Q. So what we can do then is, if that origin is the midpoint and we have 2 points that lie on the circle, P and Q are going to look something like this. So P could be like over here, so that could be P there, and Q could be somewhere there. So you just need to kind of construct a chord where that origin is the midpoint. So something roughly like that. So yes, now the challenge is to find out the length of this line PQ. Now the problem is we don't know the coordinates of P and we don't know the coordinates of Q. So we can't do like any Pythagoras with this triangle here, this PQ origin triangle, because we don't know the coordinates. So what we have to use is we have to use the circle itself and see if we can use what we know about the circle to try and work out some lengths. Now what I know the radius of this circle is 8. So I know that if we go from the center to any part of the circumference, the length is going to be 8. So if I do this let's do this in another pen. So this green line from the center to Q must be 8 long, because again the radius is 8 and this is the radius, so just call this 8 there. Likewise for this length, so from the center to P, that must be 8 as well, because again that is the radius. Quick ad break. If you're year 13, you're doing Edexcel and you're struggling, you haven't done too well with your mock exams, if you work with me for the next 3 months, you will jump up 2 grades. And if you don't, I'll work for 3. So if you want to work with me one-to-one and join my coaching service, just go to my bio, click the link, and then you can click the link to book a call with me, and then we can discuss and see if it's the right fit for you. So do that if you are interested. Now, just something to mention, I know that this diagram here that I've drawn kind of looks like a right angle triangle, so the 2 green lines and the black line. It's not, okay, I mean it could be, but in general it's not. So we can't assume that that's a right angle just because it kind of looks like one. Just wanted to mention that we don't know that's a right angle, so you can't do Pythagoras with this. So what we need to do is something else. Now what we can notice is, because we have the center there and we have this midpoint here, the shortest distance between the center and the midpoint is going to be the perpendicular bisector of this chord. So basically this line there is going to be perpendicular to the chord P to Q, because again that is the shortest distance from the origin or the middle of the circle to the origin. So if we can somehow find out how long this line is and find out the distance of this line, the shortest distance from the center to the origin, then we're going to be able to use that, because now we've got a right angle triangle here, or here, doesn't matter which one we pick. We've got a right angle triangle, and then we can do Pythagoras. So can you see a way that we could calculate the distance from the center to the origin? Hopefully you can, because we actually know the coordinates of the origin. We know the coordinates of the origin is 0, 0, and we know the coordinates of the center is -4 and 6. So you can find the distance between two coordinates using Pythagoras, basically. So we've got the center there, the origin there. We can do like a little triangle here, and we can use Pythagoras to get this length here. So we know that the base is going to be 4. We know that the height is going to be 6. So this length here is going to be 4 squared plus 6 squared, and then you square root it. So 16 plus 36, that's root 52. And then I guess we'll just write this as a simplified surd. So root 52 is the same as root 4 times root 13. So it looks like it's going to be 2 root 13. So now we know that this length here must be 2 root 13. So I'll do this in red now, this red length there. So now we can extract, for example, this right angle triangle here and do Pythagoras again with this P to the origin to the center, this right angle triangle there. So we have 2 root 13 there, we have 8, which is the hypotenuse. So now doing Pythagoras, what we can do is we can say that this length there is the square root of 8 squared, and then minus this value there squared, which would be 52, so take away 52. So 64 take away 52, that's going to be root 12. So in other words, that's going to be root 4 times root 3, which is going to be equal to 2 root 3. Sorry, my 3 there is really bad. Let me try and make that look like a real 3. So now I know that this length from the origin to P is 2 root 3. And because, again, this line from the center to the origin is bisecting P to Q, I know that this length here is also 2 root 3 as well. So the length P to Q, so therefore PQ, I just use modulus signs around it. So the length of PQ is equal to 2 lots of 2 root 3, which is equal to 4 root 3. Sorry, that square root symbol there looks dreadful, but that should be a square root symbol there. Now, in hindsight, it does actually seem a bit generous for 5 marks. So, I mean, yeah, looking at the mark scheme here, this was 5 marks of this part of the question here, and they would have accepted something like this. So, yeah, a bit of a strange one. But these specimen papers, this was from a specimen paper, and some of these specimen papers, they give out marks quite weirdly with some of these specimen papers sometimes.